Here, if the sum of first p terms of an AP is equal to the sum of first q terms, then show that sum of its p plus q terms is 0. And here p is not equal to q. See here what is given. Sum of p terms. So we write SP for that is equal to sum of first q terms. Then we have to prove sum of f sum of p plus q terms is equal to 0. Okay. Now we know the formula for sum of first n terms, that is n upon 2 into bracket 2a plus n minus 1 into d. So n indicates term number. So for SP, we can write p upon 2 into bracket 2a plus p minus 1 into d. And for SQ, that is sum of first q terms, we write q upon 2 into bracket 2a plus q minus 1 into d. And given that SP is equal to SQ, means these two parts are equal, and hence consider them p upon 2 into bracket 2a plus p minus 1 into d is equal to q upon 2 into 2a plus q minus 1 into d. Okay, now here we can cancel this 2 and multiply the this bracket by p and this bracket by q. So we get 2ap plus p into bracket p minus 1 into d is equal to 2aq plus q into bracket q minus 1 into d. Now shift these terms to the left side. So we get 2ap minus 2aq plus, I'm multiplying this. So we get p square minus p into d minus q square minus q into d is equal to 0. Okay. Now here we can take 2a common from these two. So 2a into bracket p minus q plus, see, I'm taking d common from these two. So we get p square minus p minus q square plus q into d is equal to 0. See here, when I take d common, because of this minus sign, these terms become minus q square plus q. Okay. Now simplify. Rearrange the terms. So write p square minus q square together and minus p plus q and into d is equal to 0. So 2a into p minus q plus, factorize this using a square minus b square identity. So that is equal to a minus b a plus b. So factorize this as p plus q, p minus q, and from these two terms take minus sign common, that is p minus q into d is equal to 0. Now see, we can take this bracket p minus q common throughout, that is p minus q into bracket 2a from the first term plus p plus q here and minus 1 into d is equal to 0. Now see, we have given that p is not equal to q, and that means p minus q is not equal to 0, and hence dividing both sides by p minus q, we get 2a plus p plus q minus 1 into d is equal to 0. Write this as 1. Okay. Now we have to prove SP plus Q, that is sum of P plus Q terms is 0. So consider SP plus Q. Apply the formula for Sn here. So P plus Q upon 2 into bracket 2A plus P plus Q minus 1 into D. This is the formula for SP plus Q, that is sum of P plus Q terms. Now from 1 we know this bracket is 0, and hence P plus Q upon 2 into 0, and that means SP plus Q is equal to 0, that we have to